Hello and welcome to Through the Telescope, the podcast that puts the lens on astronomy. I'm Rose Waugh and I'm an astrophysicist and science communicator.
And I'm Elliott Bruce, and I'm neither of those things, but I'll be trying to find out why we should even care about astronomy. We'll be exploring some of the big topics in the field in little manageable pieces and have some fun along the way.
So, whether you know your red giants from your red shifts, or you're not quite sure what the difference between astronomy and astrology actually is, join us as we launch ourselves into the cosmos and try not to burn up on re-entry.
So, Rose, in today's episode, we are going to be talking about galaxies. But first, as it is our first episode, why don't we talk a bit about ourselves? So, you have the most and the only astro experience. So, why don't you introduce yourself first?
Thanks for that.
You're welcome.
Yeah, so I am an astrophysicist. I'm at the very, very end of my PhD right now.
It's going to be Dr. Waugh.
I hope so. Yeah, I hope so. And I have been talking about astro online for quite a long time now. And, doing outreach in general, but definitely in recent years with the pandemic, I have done a lot more outreach virtually online and in various different formats, but something that I kind of regularly stick to rather than one-off events or whatever is talking on Instagram about astro, about my PhD experience, and definitely in a recent while, I don't know what the word is, recent, not really so recent, in the past however long, I have been spending more time, it feels, talking about my PhD and academic life, what it's like as a researcher, than actually talking about astro content, because life is just so crazy busy at the moment. But I generally try to keep my private life private.
And your public life public.
And, sometimes I feel like I have two different personalities, So it's fun but weird to be sharing an outreach activity, science dissemination activity with you, my partner.
In crime.
Yes.
Yeah. So, if anybody in the course of this does notice any tension in the room, that is completely made up because we're actually married. So
definitely
that's well
fictional.
out the window.
Yes.
But I'm Elliott Bruce, and I am actually not an astrophysicist. I have seen the sky before, and I quite like stars and such like. They look nice. And I've learnt a lot of things by osmosis from you. I also do follow you on Instagram, but I am not that regularly on Instagram.
No.
But I'm actually a chemist by trade, which in the UK always makes me feel a bit weird, because I always feel like that makes me sound like a pharmacist.
Yeah, it makes me feel weird saying, yeah, my husband, they're a chemist.
But they can't give you drugs.
No.
Unless it's like a Breaking Bad kind of situation. But I wouldn't recommend that, because I'm not very good at organic chemistry, so probably blow up. But no, I'm also doing a PhD, also near the end of my PhD, in chemistry. And I look at sort of
Rocks
with holes in.
Yes.
The holes are important. So I look at porous materials, which are nice. I look at
they have a fancy name, don't they?
They're called zeolites, which literally means boiling rocks.
I love a bit of etymology. I hope we're going to have some more of that.
Well,
this podcast.
We might do later, but for now, I think we should crack on with the episode and start talking about galaxies.
Okay. Through the Telescope is sponsored by Pick Astro, the astronomy and astrophotography image sharing app, dedicated to your images of the cosmos no matter what stage you are on your journey around the universe. No ads, spam, or fake accounts.
So today we're going to be talking about galaxies, and then a little bit later we're going to be talking maybe a bit about chocolate. So, Rose, start us off. What is a galaxy?
Well, a galaxy is a large group of stars, gas and dust all bound together by gravity.
And how big are they?
Very big.
That's very, very big.
Yeah.
Sorry.
Yeah, so Andromeda, which is a very big galaxy, I think it has like 1 trillion stars in it. It's like twice the size of the Milky Way.
Okay, so we've only got like...
500 billion.
500 billion.
Yeah, not very much.
Wow.
No, I mean, the Milky Way is not tiny.
Is that like 500 billion, or is that like... Hang on. What kind of trillions are we talking here?
I don't know if it's American or British. I don't think the British like billion and trillion exist anymore, do they?
Well, I think a British trillion exists, but probably not when it's like stars, because that's probably like NASA. Is that fair?
Yeah, I think that's probably fair. We'd have to fact check that one.
Yeah, we'll ask NASA.
I never use like billion or trillion. I always use times 10 to the power of.
Fair.
You know
So
what I mean?
if you can find out what it is in scientific notation, that'll be great. So when you talk about galaxies, I am imagining a big swirly, spirally kind of octopusy mess. Is that true? Are they all like that?
A spiral galaxy.
I guess that I prefer octopusy mess, but sure thing.
No, so galaxies are not all the same shape. They can be classified by shape. And you can classify things by whatever you want, I suppose, but shape is as good a property as any other to classify your galaxies. And there are lots of different examples. So you can get elliptical galaxies, which are basically just disks. You can get spiral galaxies, which are like the Milky Way, so they have the octopus arms that you were talking about.
Mm-hmm.
You can get very small galaxies, and generally the smaller your galaxy, the less kind of symmetric in shape it is, the more like blobby it might be, because there's less gravity to enforce a particular shape. And some galaxies have bars in the middle, some don't have bars in the middle. Some are kind of, I don't want to say spherical, but, you know,
Squished
sphere. More so than like a disc. And then you can get some really funky ones. So you can get polar ring galaxies, which are absolutely really cool. Definitely worth a cheeky Google.
Okay.
And they're basically like elliptical kind of galaxies, but then they have a ring around them. So you think like Saturn, a planet with a ring around it.
Right, so when you say elliptical galaxies, this is like, I've got like a sort of white kind of oval. Is that what I'm looking at? If I'm top down looking at it. Is that what's going on?
You got like a disc.
Yeah.
Yeah.
Is it a filled in disc?
Yeah.
Yeah, okay. And then I've got a ring around it.
And then you've got a ring around it, but the ring is typically not in the same plane as your disc. So it kind of goes around it in a weird way.
Why?
Well,
because space be weird.
Space is weird. I think, most galaxies are, if they were left to their own devices, they would probably turn out to be disks, assuming that they're big enough. But galaxies can interact with each other. You know, they can collide. They can have near misses. Just generally pass near each other, and that disrupts all of the stars in the galaxy, and it changes the shape.
Okay, so we could potentially be looking at like the wreckage of a car crash on a cosmic scale, kind of. Okay. Yeah. So I'm guessing the fact that I think of galaxies as sort of spirally things, does that mean that the Milky Way, our galaxy, is that kind of shape, or is that just like the prettiest one, so that's what we imagine?
Because we want to be the prettiest.
Yeah.
Yeah. The Milky Way, we think is yes, it's a spiral galaxy.
We don't know. We just live in it.
Yes.
Right.
Well, I mean, there's a lot of information we can deduce about the shape of our galaxy.
But we can't peek outside and have a look.
But we don't get to look at it in the same way that we can look at other galaxies. You know, you look into the sky, you point your telescope, and you see a nice picture of a galaxy.
Yeah.
And we can't really do that in the same way to the galaxy that we're in, right? Because we're inside of it.
So I'm sitting in my house and I'm looking out the windows and I can see what my neighbours' houses look like, but I've got no idea what the outside of my house looks like.
Yeah, because you'd have to go outside of your house.
Right, and I can't go outside of my house.
No.
How far outside of my house would I have to go? Trillions of miles.
Quite a long way to be able to get the whole galaxy into your picture.
Okay.
With your camera.
Okay. Otherwise I just get a little glimpse of the door or something.
Mm-hmm.
Yeah.
So, yeah. I mean, I think some things we know about our galaxy pretty well and other things not so much. But yeah, how we know what the Milky Way looks like is a really great question. And it's not straightforward to answer. But I suppose that there are a few things that we do know. We know what other galaxies look like. So it's reasonable that our galaxy is going to look similar to one of them. It's not going to
be an entirely different shape.
Yeah.
Or at least unlikely to.
Yeah.
It could be.
It could be
special.
When we look into the night sky and we see that beautiful, line across, assuming that you live somewhere where you have, a relatively dark sky, you see the lovely line across the night sky of the Milky Way. So we know that it has some sort of disc-like quality to it that we're looking into because it's relatively flat.
Okay, yeah, I don't really know. I'm guessing looking at that big streak, I wouldn't know.
Right? So you're not looking at it and being like, oh, it's a sphere.
Am I looking into the centre?
I feel self-conscious saying sphere because I get mocked by my family for the way I say it.
Why?
Because I used to call it like a Sophia for a really long time.
Sophia's a girl's name.
Yeah, and now the way that I say sphere still sometimes sounds a bit like that.
Right,
I feel very self-conscious about it.
Do you say Sphinx?
No, I don't think so.
I can't even think of other words.
Dwarf, also I get mocked for.
Well, you shouldn't say Sawarf.
Well, how would you say dwarf?
Dwarf.
Right, not dwarf.
No, not
Which is how it naturally comes out for me.
Yeah, which also sounds like what, Worf off of Star Trek Next Generation's, street name. Dwarf. Yo,
yes.
What up, Dwarf?
Yes, it does. Right, let's progress from this. And dwarf, as much as I love it. Anyway, we're not looking at that line in the sky and thinking that our galaxy is rotund.
No.
So it's got some sort of flat element to it.
Are we looking into the galaxy? Out of the galaxy?
Yeah, we're looking into the galaxy. We can look into the galactic centre. We're in one of the spiral arms.
Geocentric model. Okay.
Yeah.
Wait, so we now know we've got a spiral arm?
Well, I skipped forward, I suppose.
Okay. So how do we know we're in a spiral arm and therefore we are
So the
galaxy?
stars in the galaxy can be mapped if we know what their distance is from us, which we can determine. It's not.
Through the powers of science.
And it's not necessarily the easiest, especially when you have a huge number of stars, right?
Yeah.
But, yeah. The problem is that we can't see through stars.
Okay.
So if there's a star behind a star, we can't see it.
Hang on, sorry. This might be a really stupid question, but all of the stars that you can see in the sky,
are
they all in the Milky Way?
No.
Okay.
Well, I mean, we can see Andromeda.
Okay, but so, any star that looks like it's a dot, as opposed to, within a swirly mess.
Oh, right.
Are they all in the Milky Way?
That's not a stupid question. I would say yes.
So, I guess...
But I don't know that is true.
So I guess looking out from the Milky Way, presumably, would therefore just be looking at white dots on a black background. And looking into the Milky Way would then be the smudge. Is that fair?
I don't know if looking out of the Milky Way, if all the stars that we see, going by the logic that all the stars that we see in the sky are from the Milky Way, which we have not confirmed to be true.
Cannot confirm or deny.
Then if we were looking out from the Milky Way, then we wouldn't see anything in the sky, right? Because
Well,
that suggests that we can't see any stars. They're
well,
not bright enough.
I was more meaning like say we're in a spiral arm, apparently, then the stars that are above, whichever way is above or below, or you know what I mean, are going to be dots in the sky, but it's going to be like a black background as opposed to like a white smudge. Do you know what I mean?
No.
Okay. Well, we can probably cut this bit.
I think we should leave it. No, I'm kidding. I don't know. Right, anyway.
Course correction.
The point is, we can't see through stars. So if there's a star behind another star, we can't see it.
In a big kind of conga line.
Yes.
Okay.
So we look into the Milky Way and we can't see what's on the other side of the stars that we can see.
Yeah.
So we look into the bulge of the Milky Way, which is the centre we talked about.
Yeah.
And we can't see, like, behind that.
No.
So the map only gives us a picture of the bits of the galaxy that we can see.
Yeah.
Which, sounds obvious.
Yeah, but
as a statement.
All science is based on some really obvious statements, and then you go from there to crazy times.
So we're actually not getting a picture of all of the galaxy. We have to kind of guess what the rest of the data would look like, or interpolate, if you want a fancy word.
Right.
So you kind of join the dots between what you know and the bits you don't know to kind of fill in the gaps.
Yeah.
So yeah, we can also use velocity measurements. So you can look at stars and instead of kind of plotting their distances and stuff, you can map their speeds and the direction of their motion.
Okay.
And this tells us how the stars are orbiting around the centre of the galaxy.
Right.
So you can get another kind of map, which can tell us what the galaxy looks like in that sense.
Okay, so like, for instance, I'm thinking sort of high school classical mechanics. If you got circular motion, stuff that's, assuming it's all going round sort of together, then stuff that's further out has to be moving faster to keep up with the stuff that is closer in, as it were, so that it stays sort of, if you had sort of concentric circles. Because if it starts to go slower, then you get like a sort of, it starts to lag behind.
Yes.
And then you'd end up with like a kind of spirally bit, I guess.
Yes.
But then it would just start to look really messy, so probably not that.
Well, I think we should save this conversation for a later episode.
Somebody that knows about.
Because, there are some interesting things that we could discuss about galaxies and the dark matter that we think exists in them based on velocity measurements of stars. So let's save this. Let's park that thought.
Okay.
Because I don't want to talk about dark matter right now.
Who does? Somebody does.
Loads of people. But we're talking about galaxies.
Okay.
So
and there's no dark matter in galaxies, is what you tell me. That we want to talk about.
That we want to talk about. Right. So, yeah. So we rely on lots of things, basically, to piece together the answer to your question.
Right.
And that's basically how most science works, right?
Yeah.
Because a lot of questions aren't straightforward to answer, but even if they are, you find evidence for something, and then you hope that your next experiment also finds evidence for the same thing.
Yeah.
If it doesn't, if it finds evidence that does not fit with your current understanding, then you've got to chuck your current working theory out the window.
So what you're telling me is there's a whole bunch of different sort of categories that it could fit into from what we can see from other galaxies, and then some clever people have looked at different data and worked out, well, it can't be that one, it can't be that one, could be that one, and we've decided probably it would be a spiral. Is that basically it?
Yeah. I mean, our understanding of it is still evolving. I'm not a galaxy researcher,
Okay.
neither in the sense of astrophysics or chocolate.
Fair.
But, lots of people do research into this area, and it's a big field.
Yeah. You're more of a Cadbury's person, so...
And, so not that long ago it was thought that the Milky Way, only had like a small bar in the centre. Earlier we talked about bars and galaxies.
Yeah. And that's
not bars of galaxy. Chocolate.
Yeah.
Bars
or
inside.
pub, which would sound far more interesting.
Yes. And they're just, clusters of gas, dust and stars at the centre that form literally like a bar-like shape. You'll probably
like
get
a line,
better
a
understanding looking on Google Images. But, so it used to be thought that we only had a small one, but now lots of experts think actually it's likely that the Milky Way's got a pretty big one.
Okay, so shouldn't be like putting
previously, we might have had 4 arms in our spiral galaxy. Now maybe only 2.
Okay, I was going to say 4 is quite poor, but 2 is even worse.
Yeah.
That's nowhere near an octopus.
No, it's not an octopus. Not a space octopus.
No.
So, yeah.
Is that because... Sorry, so we... Is that we thought we had 4, and now we're like, no, it's probably 2? Or is that there used to be 4, and then a giant, galactic disaster happened, which meant they slammed into 2?
No, I think the reasoning is that if you have a smaller bar, then
right,
you have 4 arms, and if you have a bigger bar, then the more natural shape to occur is 2.
Okay, so all of these... So when we were talking before about why we think it's a spiral galaxy, and it's kind of like there's this evidence, so we can assume this. Basically, some evidence changed, so one of our assumptions changed, kind of, so that then had consequences on our other assumptions.
Yeah.
Okay, that does sound like science.
Yeah.
So that's the Milky Way, our home. That's nice. Who have we got living in the street? Who are our neighbours?
So I think our closest neighbour is Canis Major Dwarf Galaxy.
That's the worst name for a galaxy ever.
I would say yes, but I think actually, when you get to the point of a number plate, I think that's worse.
Right.
So maybe it's not doing too bad.
Canis Major Dwarf Galaxy. Well,
yes.
So I think I can get this one right. This is actually this is a galaxy which is quite small. It's a dwarf galaxy. Vaguely in the area of Canis Major, also known as Big Dog, which is a constellation in the sky.
Good job.
And so that's the closest one.
Yeah.
Is there anything else to know about Tiny Dog Galaxy?
Well, it was only discovered in 2003.
Okay.
Which I suppose now is 20 years ago. Which
so
makes
they've
me
had
feel
20
old.
years to come up with a better name, and they've still stuck with Tiny Dog Galaxy.
I don't know. But, it's pretty small. And like you say, yeah.
So you say it does what it says on the tin.
It does, yeah.
It's Big Dog, Small Galaxy. That's what it is.
It is, pretty close to us, all things considered. It's about 25,000 light years away from us, and about 42,000 light years away from the galactic center. So we are on Earth, going around the sun.
Yeah.
The sun is in a spiral arm of the galaxy, pretty far away from the center, which is no bad thing.
Okay.
So this galaxy is closer to us than to the center of the galaxy.
So it's 25,000 light years from us. So that means that if light left that galaxy 25,000 years ago, it would be hitting us right now. So that the light that's coming from that galaxy is from before the pyramids, and I don't even know what comes before the pyramids, but
I don't know.
A long time ago.
Yeah.
Humanity ain't up to much, possibly. No pyramids, at least.
If that's your requirement for humanity being up to much, then I think we're in a lot of trouble. But yeah, so yeah, it was only discovered relatively recently. I know, 20 years. Yeah, but still, despite being so close, you might think that we would have known about it for longer, but we didn't, because our own galaxy is obscuring our view of it. So, yeah, and it's not, mega bright, so we didn't. So yeah, so this big dog, small galaxy, as you've coined it, is orbiting the Milky Way, or the centre of mass of the two galaxies, I guess, if you want to be precise.
Right.
And we are tearing it apart, or the gravity of the Milky Way is tearing it apart. So, a bit tragic.
Sucks to be big dog, small galaxy.
Yeah. There's also Sagittarius Dwarf Elliptical Galaxy, pretty close by.
I think I know what this one's about too.
Mm-hmm. And this was discovered in 1994, so a bit longer.
Okay.
And again, it's pretty dim, so it took a long time to be discovered, and it's on the other side of the Milky Way. So,
right.
Yeah, it's about 70,000 light years away from us, and 50,000 light years away from the centre of our galaxy.
Okay.
So our galaxy is definitely obscure.
Don't want to go to because it's a rough neighbourhood. So, this is from 2003 and 1994.
Yeah.
So, is that why... So, if you asked me, what is the nearest galaxy to us? I would say, well, Ro, it's obviously Andromeda. I would not be saying Canis Major Dwarf Galaxy. Is that because, basically, like, textbooks and popular culture are like, Andromeda is closest, and then all of that happened before 1994 and 2003. Do you know what I mean?
No.
Is it the same thing about Pluto being a planet?
It is a little factoid, isn't it, that we seem to have all absorbed. I don't know why. I think maybe just because it's a big galaxy, so... I mean, it's relatively close to us, I suppose, all things considered. It's within the local group, which is a group of galaxies that are all gravitationally bound to each other. They're all orbiting each other.
So are we... Right, so when you say, like...
And Andromeda is the big one in the local group.
So are we all orbiting around Andromeda?
Yeah.
No.
Well,
yes. We're all orbiting around the centre of mass, which is... This is the biggest boy in the neighbourhood. Right. So does that mean that instead of, like... Because I would kind of imagine they're all just spread out randomly, right? But actually, there's, like, clumps
of galaxies, yeah.
That then spin around themselves, and within that, there's, like, stars spinning around the centre of the galaxy.
Yeah, so if you think about the solar system, I think people are kind of accustomed to the idea of the solar system and how we're maybe not going to go into too much depth, but there's a star and there are planets that go around it, and it all comes from stuff that's there before, and it forms into a star and it forms into the planets as they go around. A lot of the kind of physics that you can think of there is just gravity, right?
Yeah.
So the same thing applies as you go to larger and larger scales.
Right.
So just as you can have planets going around the star, you can have stars going around something. A black hole makes a galaxy. You can have galaxies going around each other to make a cluster of galaxies.
Right.
Does that make sense?
Yeah.
And in between, all these things are just not very much.
Right.
So, there's not very much between us and Mars.
Yeah.
It's empty space.
But then between Mars and Jupiter, there's like some rocks.
Yeah, but most of space is empty, is what I'm trying to say.
Yeah.
And then between us and the next star is also pretty empty.
So does that mean are there some galaxies out there that just they're on their own? They're just flying off with no galaxy friends? Presumably. But most galaxies have mates with them.
Well, whenever galaxies get near to each other, they're both of their gravitational forces are going to influence each other.
Right, yeah.
In one way or another.
Yeah.
So that might be that they end up getting bound to each other and orbiting and being part of a cluster. They might get, some sort of flung off in some way.
Mm-hmm.
They might collide in some way.
Yeah.
Other close galaxies involve the Large Magellanic Cloud and the Small Magellanic Clouds.
Right, I can't tell you anything about these ones, apart from they are different sizes of Magellanic Clouds.
Yeah. And they're named after a dude.
Magellan.
Yeah.
Did he go around the world?
Yeah, he did. Anyway, the galaxies that you might have actually heard of, and they are visible with the naked eye from the southern hemisphere.
Okay.
So, as with many things in astro, they were known about for a really, really long time by observers in the southern hemisphere, but they're named after Magellan. Blah, 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 blah. We can cut this.
We'll call him Madge.
They're named after some white dude after his trip around the world in 1519.
Right.
So, yeah.
Okay. Magellan.
Mm-hmm. Was that a cue for me to say Magellan?
No.
Okay.
No, it's key for you to say dwarf.
Anyway,
Anyway.
moving forward.
So what are the Magellan... Magellan... what are the... what are the clouds of Magellan?
Some galaxies.
Oh. Why are they not called Magellan's Galaxy?
I don't know. I think because when you can see them with the naked eye, and you can see that like splodge
Okay.
in the sky.
Right.
That would be my guess. Anyway,
So
a lot of things.
The first like European or whatever to pop down to the southern hemisphere and go, there's a smudge in the sky.
Yeah, probably.
And so we
And
called
write
it a
about
cloud.
it. Probably.
Right.
Yeah, and names in astro tend to stick. Once something's been written and published,
I see.
names tend to stick.
Yeah, that's pretty... Yeah. Yeah. Whereas if you discover one more recently, you need to call it small dog, big... No, big dog, small galaxy.
You probably have to call it like MG295C X1. I mean, I made that up, but
Isn't that the Enterprises... USS Enterprises...
I wish I knew that off the top of my head, but I don't.
It's NG...
I think that all galaxies, anyway, they all have, in various systems and databases, they all have number plates for names as well.
Okay.
Same with stars.
Yeah.
So they
You
can
need to-
often have different names, multiple names.
Oh, jeez. But so Andromeda is not our closest bud.
No,
No. Well, that's a shame.
no, it's not. It's definitely, to my knowledge anyway, unless it's been updated since 2003, big dog.
Small galaxy.
Small galaxy.
I think that should either be like somebody's autobiography or like a new album. I don't really know.
Yeah. Maybe if I ever get rich and famous,
Yeah.
that'll be my
Big dog and a small galaxy. Roswell.
Yeah.
But one thing I do know,
Mm-hmm.
or I've heard, because I did also know that Andromeda was the closest galaxy, and that is not true. But are we going to smash into Andromeda and all of our lives will change forever as we're ripped apart?
Andromeda and the Milky Way are on a collision course, yes. They'll collide in about 4.5 billion years. So if you're...
So I don't need to worry for a while.
No, I don't
Okay.
think you need to worry about it. I don't think it needs to keep you up at night. I'm sure
Right.
there are many things that do keep you up at night, but I don't think this needs to be one of them.
No.
And, stars in galaxies are very far apart. So it's unlikely that the stars themselves will actually collide when the galaxies collide.
Whoa.
A very, very small number of them will do, because there's a huge number of stars, and that's just how maths works, right?
So we're just going
But
to...
statistically speaking, the vast majority will not.
What is that even like? That's like such a weird sort of...
Yeah. So colliding is maybe not the most appropriate term. It's more of a galaxy merger.
So it's
which
kind of...
is,
Wait, are we
you
going
know,
to
what it's
form
called.
one big galaxy? Or is it just going to pass straight through us? Is it like two ghosts bumping into the night, or is it like kind of like blobs sort of coalescing?
The galaxies will collide, and there'll be some sort of probably, a big galaxy left over. It might mean that there are different ways that they can merge, right? So
You mean it
you
could be
can
Milky
have
Dromedar
something
or
that becomes
Andro
more
Way?
like one, and you lose a few bits, or you could have like the two pass by and they change shape, and maybe one gains quite a lot of stars and the other loses quite a lot of stars, but you're still left with two things. There are like various different ways depending on how all the mass is moving through space. And it takes huge numerical simulations to model what the final thing would look like.
Right. So we're not... And given that we don't know for definite, for sure, what our galaxy looks like, I guess that probably doesn't help working out what we would end up looking like as a sort of combined mega galaxy, or not.
Yeah, I mean, not if you want like a mega exact, every star in exactly the right place.
Well, we just
simulation.
halved the number of spiral arms.
But I think that probably I'm a theorist, right? So I like to simplify things when I make a model anyway.
Yeah.
But I imagine that the overall shape is probably more important rather than the exact shape. So we know with relative certainty that the Milky Way is disk-like.
Right.
And that's probably more important than how many spiral arms does it have,
Right.
for example.
Yeah.
And the inclination, how the plane of our galaxy and the plane of Andromeda relate to each other is probably also quite important.
I guess also maybe...
it's all that kind of thing.
The stuff in the middle, presumably, is going to be more kind of disrupted, like the galactic centres of the two bits. Because they're going to be where all the mass is, really, right?
Mm-hmm.
And they're also presumably going a bit slower round. So, like, they can sort of scoop out bits further away from the centre of the other one. Do you know what I mean?
Probably.
Maybe.
I've never really thought about it in that much depth
that's
because I'm
fair.
not really...
I think...
Galaxy merger is not my research interest or specialism. So we might
think,
have to, ask an expert on this one.
Yeah, and I think that, there are going to be some people out there that their work is involved with this, but I think also, like you were saying, you like to simplify problems. I think the simplest solution to the problem is it's going to happen in 4.5 billion years.
Mm-hmm.
So, probably need to study more what I'm going to have for breakfast tomorrow than what am I going to do about galaxy mergers.
Whilst
instance.
I understand where you're coming from and I do like to simplify problems, I
don't
don't
have
want
breakfast.
to simplify myself out of a job.
That's fair.
So, yes.
Yeah.
But yeah, that's all really, I think, for galaxy mergers.
Okay, well, that's something. So, Andromeda, I'm guessing, because it's not called, like, NG7493 or Big Dog Small Galaxy, Andromeda sounds older. So, is that easier to see? Did we see that through telescopes? Whereas, I guess, the newer ones need, like, super mega kit.
Yeah, you can see Andromeda with a telescope or without a telescope.
Okay.
And if you have a dark enough sky.
Where do I need to be?
I've seen Andromeda quite a lot of times.
So do you need to be in the Northern Hemisphere to see Andromeda?
I'm going to say yes, but we'd need to fact check that as well.
Any Antipodeans listening? Confirm or deny?
Yeah. At us on social media with your pictures of Andromeda or other galaxies if you want.
Yeah. You could be anywhere in the Southern Hemisphere. You could be in Peru or Malaysia. You don't need to be in Australia or New Zealand, for instance. But
yeah. And there are various galaxies you can see without big telescopes. We talked about the large and small Magellanic Clouds earlier.
God, he needs a better name.
So, yeah, you don't need a big telescope. If you're an amateur astronomer and you have a small scope, then you're going to get better views for sure than just using the naked eye. But yeah, they do observe and take fantastic photographs of galaxies without the huge billion-dollar
Price
things
tag
that research institutions have to pay for obvious reasons.
Well, thanks very much.
You're welcome. I hope you learned some stuff about galaxies.
I did. Mostly, I learned that Andromeda is not our closest friend. And our closest friend we're actually tearing apart, which doesn't sound like what you should do to your closest friends.
Yeah, we do not endorse that.
Okay.
On this podcast, we don't endorse
Unless they're into it.
destroying your best friends.
Welcome to part 2 of Through the Telescope podcast episode on galaxies, where I'm going to talk about something a little bit different, but related. So I don't know a huge amount about astronomy, but I do like astronomy, and I also like words. I also don't know a lot about words, but I do like words and where they come from. So turns out that galaxy as a word comes from the ancient Greek, don't you know?
Oh, that makes sense.
Yeah, it's in science it's generally either the ancient Greeks or the Romans, so, nobody else gets a look in. I wonder why. But anywho, but Galaxias.
Sorry.
Galaxias. Apologies to any ancient Greeks who might be listening for my pronunciation. But
If you can speak Greek,
modern or ancient?
yeah, well, I think, are they not supposed to be relatively similar?
I don't know.
Oh,
How would you know?
If you can speak ancient Greek, then please do at us and tell us how to pronounce this, because I'm going to be sniggering the whole time.
Okay, Galaxias is actually the ancient Greek for the Milky Way.
Really?
Yeah.
Right, so we've called them all Milky Way.
Yeah, pretty much. Also,
Interesting.
So for a long period of time, also, if you wanted to talk about the Milky Way, you just talked about the galaxy with a capital G.
I think that's
can
still
do.
pretty normal, yeah. But it helps to specify.
Yeah.
So
yeah. Other galaxies
yeah.
are called island universes, which sounds pretty cool.
that is pimpin'.
Yeah.
Yeah, I like that.
But
I'm going to start using that.
I know the issue was people were then like, it doesn't make sense. The universe, we're just going to call everything the universe, so we can't have universes within the universe. But island universes sound way cooler.
Yeah, that definitely sounds cool.
And also feels like it makes more sense from like a kind of like Marvel Cinematic Universe, Star Wars universe, especially Star Wars is like another galaxy far, far away, a long time ago.
Yeah.
But anywho, Galaxias basically means milky spot, smudge, circle, dot, something like that.
All pretty accurate descriptions.
Yeah, so the ancient Greeks looked up at the sky, as many people have done, and have gone, oh, there's a milky smudge. Do you know what their, origin story for the Milky Way was?
No. I have a feeling I'm about to learn, though.
Yeah, so as with all things ancient Greek, there are multiple versions. And with a lot of things ancient Greek, it starts with Zeus having relations with somebody. This time he pretends to be somebody's husband, and that leads to Hercules being born, or Heracles, as I guess they'd call him. And somehow or other, Heracles ends up getting nursed on Hera's breast, and she, for various reasons, such as he's just a bit too aggressive on there, is like, get this thing off me, the brat. And in the process, a little bit of milk spills into the sky, and that's the Milky Way.
Well, can confirm, as someone who is breastfed, that is a perfectly believable believable story. Yeah.
I think despite sort of a lot of the different potential ways that it could have happened, and also the ancient Greek gods being just kind of general jerks, it's kind of nice in a way, because it's kind of like, the things of life, I guess, like sustenance, it's like
Yeah.
big clouds of like life, but not life, but like nature. Unless
Getting
there are
hippie
things
there.
out there. I know, I'm getting a bit kind of,
Yeah.
what can I say? I had some brownies beforehand, and I did not have brownies beforehand.
Yeah.
But yeah, so there you go.
The more you learn, huh?
So also that galact or galac beginning is also, if you remember in, I don't know, what's it, standard grade chemistry? So what's that, like GCSE sort of level chemistry? Do you remember when we did sugars?
Yes.
And he did like sucrose, which is
Yeah.
like sweet sugar, fructose, fruit sugar, which was the best one. I think everyone could agree on that.
Yeah.
And you had lactose, which is milk sugar.
Yes.
But galactose also means milk sugar.
I see.
Yeah. And then some people in Switzerland created white chocolate. And the way that they did that was, or the reason they did that was they had some kids that had just like had TB or whatever. And they were like, we really need to get some fat onto these children and also like nutrition. So they wanted to give them milk, because as we all know, milk is the best for everything ever.
Questionable, but yeah.
But yeah. And the kids were like, no, that's for babies. Like, I've had TB, but I don't want to be a baby amongst the other kids or whatever. So somebody had the bright idea.
That's a really weird one, I gotta say.
I know, right?
I think lots of people drink glasses of milk.
This is like the 30s or something. And I'm not sure if that is relevant to that at all. But somebody had the idea of, well, why don't we just shove, like, cocoa fat into it to make it, like, a solid.
that
and
makes
then
sense.
It's, like, a thing. And then the kids ate it and they're like, oh, this nutritious bar is really nice. Do you have any more? And it turned out it was quite popular with kids. And so they
wonder why.
I know. So they then started selling this. And it's now the Milky Bar. That's where it comes from. But in continental Europe and also in South America, I believe, at least in parts, it's still called Galac.
Oh.
So there you go. But it also made me think, in chocolate in general, there's a lot of space themes.
Yeah, I was going to say that. Yeah,
So
the Milky Way bars.
You've obviously got Galaxy. I don't know where that comes from, but I could imagine that just being a milk bar, but you're like Galaxy. But yeah, you got Milky Way. You've got Mars bar, but unfortunately that comes from Mr. Mars, apparently.
Oh, that's tragic. I'm going to just ignore that and keep believing in my heart that it's space related.
Yeah, but like, I don't know, is it just that space is exciting and chocolate is exciting? Or is it like otherworldly? I don't know what the kind of advertising...
Yeah, it does make you wonder how much it's just coincidence of etymology.
Yeah.
You know, if galaxy already existed and things, and then it's maybe not a large step to get to Milky Way if you already got like Milky bars and stuff.
Yeah.
And then there's, a bar that's already named after a space thing. Maybe Milky Way doesn't seem so, you know what I mean?
Yeah.
I don't know. It's interesting. Is it because space is awesome, which it is, or is it just purely coincidence?
Yeah.
Yeah.
I don't know. So if anyone's got any like chocolate research,
Insight,
yeah, then that would be good to know.
or other, suggestions of chocolate-related products with space names in your country or whatever.
Yeah.
Please send them our way.
Any other foods, to be honest. To be honest, I'm not a huge chocolate person.
No,
I will put some away.
Actually not myself.
But
much to my supervisor's dismay.
Yeah, preferably I would like some savoury space food.
Yes.
But can something that's just popped into my head is, can astronauts eat chocolate? Like, they're on the ISS. Because, like, surely it's going to be melting in your hands. It's going to be, like, getting sticky.
I mean, maybe they can't have real chocolate. Like in the US, they don't, no offence to any US listeners, but they don't have real chocolate. You know, like in hot countries, you don't get proper chocolate.
Because you don't have the melt in the mouth chocolate, because the room temperature is too...
So it doesn't have the same experience. It's not the same texture, but it also just doesn't... Yeah, like the melt in the mouth thing is it's an important factor for chocolate. I mean, so I'm someone who does have quite strong chocolate opinions. For someone who doesn't actually eat very much chocolate at all.
Well, that might be one.
I think the two are related.
Yeah, if you didn't have such strong opinions, you'd be eating everything. But
yeah, so maybe they just can't have, you know, that kind of chocolate.
I guess.
Maybe it just has to have, like, has a higher sugar content, I suppose. Is that why it's always so sickly sweet when you get, like, American chocolate?
I don't know, it might be that
more sugar, less...
Is it that, or is it lower fat, higher fat? Should know that one. But
it doesn't feel or taste right anyway.
But then I guess, you know, chocolate comes from Central America, so in a way, you know, kind of like, I mean...
Yeah, we're probably wrong in Europe, the way that we make it.
Well, I don't think that necessarily chocolate bars you get from the United States are any better, but, like, to go for the traditional sort of chocolate drink of the Mayans, I think it's the Mayans, you know, in a kind of chocolate purism.
I definitely couldn't do that because I despise chocolate drinks.
Yeah,
I despise chocolate milk. I despise hot chocolate. I'm really sorry. I'm going to get so much hate online for this.
I'm also not a bitter chocolate person, so I couldn't have, like, straight, like, chocolate beverage. But
I do like it, but I think it has to come with a sweet thing. You have to eat at the same time or drink at the same time. But yeah, there are very distinct products, aren't they?
Definitely.
This is definitely diverging a lot from space.
Yeah, I do diverge from things quite a lot. Anyway, very divergent.
Yeah, I do feel already like this has turned into me info dumping on you, and then you info dumping on me. Yeah, it's quite nice. Yeah. I hope everyone else appreciates our info dumps as much.
I hope so. So that just about wraps things up for this episode. Please, can we encourage you to subscribe to Through the Telescope wherever you find your podcasts, and, if you like, you can leave us a nice positive review as well. It really helps the show, and it makes it easier for more people to find us.
Feel free to send us any comments, questions, or suggestions of things or people you'd like to hear about or from in future episodes. Or perhaps to put yourself forward to chat about your own astro research or experiences. As always, you can find us on Instagram at Through the Telescope Podcast, or you can find me at astrophysicist_Rose. You can also find us on Twitter at The Telescope Pod, and you can contact us by email at throughthetelescopepodcast@gmail.com.
And with that, we'd like to thank you very much for listening, and we look forward to seeing you again next time.
Bye.